Good evening, everybody, and welcome to the second virtual meetup of the Ipswich AWS User Group. Welcome back. Tonight's kind of focus will be around infrastructure as code and some of the new tech that's in that area. So that should be exciting. Just to go through the run order. So it's me blabbing for these couple of minutes, and then we'll go into a CDK CloudFormation SAM demo with two AWS architects. Ben, who was going to give the talk, had sadly double booked himself on some personal events. So kindly we have James and Nitin that's kind of jumped in and taken it on and taken it over. So thank you very much for them. And we hope Ben's having a good night, whatever he's up to. So they're going to do a presentation, then they're going to do a demo, and then we'll take Q&A afterwards. If you pop your questions in the question section, I'll read them back, but I also will try and open the mics up if I can for a Q&A after that. And then after that, we've got Alex will be talking about the very new App Runner that only came out, I think, a couple of months ago. He's given it a bit of a shakedown, and he's going to give us a bit of a run through of what he's done there. And we'll take Q&A after that. And there's one or two little other things I would like to just highlight after that, and go through when our next event will be, and some other things to look out in the wider kind of AWS community. So therefore, let me just say some headline thank yous again. Thank AWS and InWisdom. As just last time, we're not sponsored by these companies. They don't give us money, but they give us help. So AWS help in terms of some of the organizing and also paying for the meetup, some of the meetup stuff for us and help facilitate it. So we thank AWS for their continued support. And we thank InWisdom, which is a company that I work for, because we're using their go-to webinar platform. This time of night it's not that busy, so we can hijack and take it over. So thank you again to them to let us hijack in that. It makes the virtual meetup possible, and that's all great. Now, so our first talk will be based on infrastructure as code. I am now going to duly hand over to the AWS guys. So we have Nitin, who's a solutions architect at AWS. He mainly works in small, medium-sized businesses in the UK, helping them to build well-architected architecture on AWS. Before joining AWS, he contributed to the UK's open banking payment standards, which is quite cool. As one of the key authors of the functional and security API specifications. In his spare time, he enjoys running, CrossFit, and solving jigsaw puzzles with his kids. James is also a solution architect at AWS, and he works in the healthcare customers in the UK to help them design and implement solutions on AWS. James enjoys cycling through the English countryside and working on his car. I wonder what kind of car that is. Maybe James will tell us in due course. So let me now make Nitin the presenter.
Thank you, Phil, for an awesome introduction. Okay, perfect. So yeah, as Phil mentioned, thanks for the kind words, Phil. And yeah, I'm Nitin Tiwari, Solutions Architect at AWS. So in prior lives, I've been a developer, mainly Java developer for around 10 years before moving on to the application solutions and API architecture. That is where I got the opportunity to work with open banking to design the functional and non-functional specifications, mainly security standards and payment standards. And then I joined this journey with AWS, which is more learning and then helping customers work backwards from the customers and help solve technical challenges for them. So that's a brief introduction about me. James, do you want to add something from your side?
Yeah, thanks. So yeah, my day job is helping healthcare customers with AWS. And then in a prior life, I did a lot of work with DevOps and pipelines and automated infrastructure builds and all that kind of thing. So that's where my interest in CloudFormation and its related technologies came from. And then when I'm not doing my day job, I'm mostly trying to get my VW Corrado to work. At the moment, it won't start. I have a new starter motor sat on the floor down next to me, so that's hopefully this weekend's project.
Nice, nice. Okay, thanks, James. So I'll crack on in the interest of time. So thanks everybody who has joined. Very excited to go through this presentation. As developer from my previous background, I still feel quite hands-on and keep trying things. This is a topic close to my heart. Infrastructure as code, and specifically on AWS. So we're going to look at this presentation from the perspective of best practices and an introductory session, and then we'll leave you with a demo and some good links to the references and where do you go from here in your basically learning expedition. Okay. So from the agenda perspective, we're going to touch upon the basics, okay? And after that, we'll look into basics of infrastructure as code, then put it in perspective how the CloudFormation service, AWS CloudFormation service, implements that standard or practice. Then we'll look into best practices of AWS CloudFormation. And then we touch upon the AWS Cloud Development Kit, commonly known as CDK. And then James will take you on with a hands-on demo using AWS CDK. So let's touch upon the basics. So most of the applications, modern applications, are actually have many components. The businesses have always started small and then grown gradually. So if we take an example of a simple 3-tier web application, which you can think about a front end, a back end, and a database, then you kind of creating multiple components. And these are the blocks, basically front end, back end, and databases, which are basically of application, but you also have a lot of components which actually bring them together. So think about the networking requirements, the security requirements, the way they react to the peak request, or for example, like auto scaling, how the application reacts to any surge in the traffic. So these are additional aspects which every modern application has to think about. And what we as a developer or as a DevOps personnel, we have a journey as well. So if we take this presentation in terms of me starting on AWS and trying to build an application, where would I start? So my first instance probably would be to go to AWS console. I have a very simple application. Probably I'll start with, let's say if I have a 3-tier web application, I will start with provisioning a database, deploying a database with our schema, then deploy the backend server and work backwards, from like bottom up. So from the stack, we'll just create the data layer, create the servers for our backend application, create the servers for our front-end application, and we use AWS console. So that is how a typical journey starts. And so what we will do, so we have nothing else. We work manually through this AWS console on this journey of deploying our infrastructure, like creating our infrastructure for deployment of our application. We will navigate through AWS console, and for this process to be able to replicate in future, we will try to create a runbook or wikis in parallel, taking snapshots of the screens that we go through, putting the values that we chose for certain labels, documenting them. So this process is manual, as well as creating documentation to make it work better. So this actually works for the smaller companies and with the smaller workloads. And it worked very well. it gets you started pretty quickly. But what it brings with it is that you cannot reproduce it again and again. For example, AWS releases services all the time. There are currently 200 services. 10 months ago when I joined, they were around 175, and now there are 200 plus services on AWS. So with the new services being launched, the existing services also get new features. And when the new features come in, there will be some changes into the AWS console, and then your wiki and runbooks will become obsolete. So there is a regular maintenance of maintaining your documents. They're error prone as well, because it's very easy to miss one of the steps and make errors, and it's definitely time consuming. So where we went ahead on this journey to actually deploy or create our infrastructure, we started as a developer, we would think of trying to codify it. In AWS, all the services have APIs. So as a developer, my first instance would be that, okay, why not I codify the whole runbook that I had? So I would go ahead and start writing programs, call the AWS APIs directly, provision my infrastructure. That would be called as a smart play, because I can use AWS SDK to create my, for example, VPC structure, create security groups, create database instances, and then bring it all together, tie it up in a program, and run it again and again. So this is one level up from being manual, but there are concerns. So what if an API call fails? Do we have the whole mechanism of retry and managing the failures? Well, how do I make updates to the structure? So I have one script or multiple scripts to create infrastructure. How do I update the existing infrastructure that my script created? And how do I know if a resource is ready? So because there is a case of eventual consistency, these APIs which you call on AWS, they may not give you the results straight away. Then you will have to call a put API, for example, to create a resource, but then you'll have to follow up with a get API to see what is the status of that resource. Then last but not the least, how do I roll back if something goes wrong? So these are the questions which come into the mind when we are actually scripting it. So the next stage comes in, which simplifies a little bit and also solves quite a lot of problems. So that is where the declarative programming came in, and we call it infrastructure as code as well, where you actually utilize a middleware or a service which would actually consume a declarative format of your infrastructure and produce into something which AWS understands, or basically translate them into something which could be executed on AWS. So basically call AWS APIs. So there are two quite common examples here: AWS CloudFormation service and HashiCorp's Terraform service, which both consume a simple text file, which could be a format, for example, JSON or YAML, or in case of Terraform, HCL, and consume those inputs, and then take those instructions which are there in the file and convert and make the appropriate calls into AWS to create those resources, provision those resources, and manage for you. So there is a lot of the problems which were there in manual and scripted, they get addressed by this middle service in the picture. So this is easy to automate and it's reproducible. So let's dive deeper into the CloudFormation service. Let's start with a basic example of infrastructure as code using AWS CloudFormation. What you see here is basically two extracts out of AWS CloudFormation service, and it has a tool called AWS CloudFormation Designer. So Designer is basically a graphic tool for creating, viewing, and modifying AWS CloudFormation templates. We'll come to that, what is AWS CloudFormation template. We'll address that in the slides further. But with this Designer, you can actually diagram your template resources using a drag and drop interface, and then edit the details using integrated JSON and YAML editor. So on the left that you see on your screen is basically an extract, a screen grab of that editor, and on the right is basically the Designer. And if I can just give you a quick example of how this file or this textual instructions work, that specifically on line 4, you would see that it lists out a couple of resources. So for example, my repo and my C9 environment. And you would see that there are very few lines. For example, it defines what is this resource. My repo is of type. So it is a code commit repository, which is basically a Git repository, and a code commit is another AWS service. And then there is a C9, my C9 environment, which is basically of type Cloud9. And Cloud9 is basically a browser-based IDE, so integrated development environment, just like Visual Code or IntelliJ IDEA. And this, in this little snippet, you can see that when we create a Cloud9 environment, it is backed by an EC2 instance. So M is an EC2 instance. And you can see that how the repository URL is being a dependent attribute of the my repo. So the get@, is a function which actually calls the resource and clone URL HTTP. So creates a dependency on the previous resource. So basically gives you the power of how you can write textual instruction, declarative instructions in a text file, and let your CloudFormation service know that how you create the resources, underlying resources of certain type, as well as how to create dependencies and relationship between them. So this is a simple example. Let's go further into the detail. So how does infrastructure as code work with the CloudFormation service? Okay, so basically, CloudFormation is an API wrapper. So it wraps the AWS KPIs and creates a very simple interface for you in terms of a declarative instruction or declarative like file of declarative instructions. So let's say when you click on create EC2 instance and go through the wizard, in the end, web console triggers an API calls to the EC2 service, and those information you place through by the wizard are all passed on as parameters. Similarly, with CloudFormation, you can essentially find that all of those parameter names for CloudFormation resources are comparable to the API of the service. So if you look into the CloudFormation document, you will see that there is these are the resource types. For example, my C9 environment, Cloud9 environment, or code commit repository. The parameters that you can pass basically are one-to-one match with what you can do on the front end AWS console, or there and in some cases there are some essential like some defaults taken, and because the services are like improved all the time, the new features introduced, so there would be additional enhancements on the future roadmap, but you can actually map them one-to-one to the AWS console input parameters. So how does this work? Briefly, that you would code in text files, which could be YAML or JSON, or you could use sample templates as well. Upload these templates into a CloudFormation designer. Either you can copy paste it, or you can actually upload your YAML file to S3, and on the CloudFormation service, you give the S3 URL. And then once you say create a stack, it will actually go ahead and CloudFormation service will read out your declarative instructions and then create resources, use your parameters if you have defined, and then what comes out is basically a stack and resources provisioned as a running environment. This service is free for use. You only pay for the resources that this service creates. It is available in all regions, and these APIs are all called in parallel. So unless there are dependencies defined, you would see some of the resources can be created in parallel. And on the CloudFormation service, you can always see the events which are generated with every resource being created. So you can have the monitoring as well. So yeah, very briefly, that this is a single source of truth to deploy the whole stack infrastructure that you can replicate and redeploy again and again. It controls your versioning and infrastructure application together. You can store your YAML files or JSON files within GitHub repository and manage it via version control. You can also build CI/CD pipeline using this. So for example, look at this, like dev, test, staging, and you can put them through the whole software development lifecycle. So let's touch upon some best practices now. And this is where I'll introduce the core artifacts which I've been talking about, for example, template and stack, and define what they are. So CloudFormation introduces 4 key concepts. First one is template. A template is a JSON or YAML, a declarative code file that describes the intended state of all the resources that you need to deploy your application. Next is a stack. Stack is basically a group of resources and their intended states, and it manages the association within your template. You can define the stacks and how the resources are managed together. So, and the next one is a change set. This is very very sought after feature, because what happens is this will let you on CloudFormation servers or using command line as well. Once you have the CloudFormation deployed and you want to make any updates, this change set will actually give you what all resources are being deployed or changed since your last deployment or even in the first deployment. So basically, it's a preview service which lets you know what are the commands or what resources will be created by this operation: create, update, or remove. And the last one in this list is a stack set. Another very interesting feature, heavily used and very useful. So stack set is a group of stacks you manage together that can replicate a group. It is kind of an advanced development where stack sets extends the functionality of stacks by enabling you to create, update, or delete stacks across multiple accounts and regions with a single operation. So you can see the 2 regions in the place. So stack sets allow you to manage them across the accounts, across the regions. Very briefly touching upon the syntax of the template. You can write the templates in either JSON or YAML. Very common formats. The only reason why I would prefer YAML is because you can add some sensible comments, and this helps to do the development across the team. So if you have a team like of 10 developers with logical comments, that this is like a section for let's say CloudFront or is specific to EC2 instances, and so on and so forth. Okay, so some best practices around how do we author CloudFormation code. And the recommended way is to use IDE, and most of the IDEs have the plugins which help CloudFormation templates to be created easily and help check the syntax. Also, there is an open source framework called AWS CloudFormation Linter, CFL Lint, which can help you check the syntax of your CloudFormation template and avoid any validation errors. The project is on GitHub, and it also helps you create many rules around your CloudFormation template as best practices. The way you have best practices in your application code, you can have a list of best practices for your CloudFormation template as well. Template development, and you can add them into CFL Lint configuration files, and this gives you just like you would use like a Sonar for your application programming, you can use CFL Lint. Best practices around stacks, how we organize the stacks. So this is specific to CloudFormation, AWS CloudFormation, but the principles are quite generic, and you would like to apply across any IAC tool that you use. The first thing is that you layer your application to reduce blast radius when updating resources. So what does that mean? So you separate the stacks which are basically more common, or they could be reusable or isolated. For example, identity and access management or security related components or resources that you want to create, have them separate. So they are reused, and for example, if you have to add any good best practice, you update it once and it gets reflected into any stacks that are using that particular stack. You can use it in multiple isolated environments for testing, For example, you can create network boundaries which are specific to staging environment, production, or development, and have them separate. And then also, this also makes your files easier because you can create separate stacks and separate template files. Parameterize as just like a common coding best practices. Parameterize some of the values. For example, do not hard code passwords. Of course, definitely never. But for passwords, etc., you can use secrets manager, and any other parameters. You can also use parameter store from AWS Systems Manager, and instead of hard coding the parameter values. Another very sought after feature is drift detection. So in your journey, in our journey, when we all started with AWS console, we created some resources, and at some point we realized that okay, it's not actually manageable. So we started making. So what we did is that we went to CloudFormation. But when we're working with CloudFormation, we also realized that okay, there some at times you have some critical changes that has to happen immediately. You do not have time to update your CloudFormation template, take through its review process and deploy it. So maybe your first line of support will say, okay, there's a small change, I will do it in the on the AWS console itself. But that's where the deviation happened. This deviation is called drift in this terminology. So you would call a resources drifted when if any of its actual property value differed from the expected property values. In the screenshot, you will see that the expected or the initial CloudFormation template suggested that an EC2 instance should be created with T2 micro, but it's now T2 nano. So the drift detection service will actually show you those changes, and then it's up to you how you make those decisions. There is a feature called resource import which you can use to, and it's recommended to help remediate drift by importing a drifted resource. So let's say if there is an unwanted change, you would like to re-import a drifted resource to overcome that change instead of modifying it back or reverting it back, so that your stack is always complying with the CloudFormation template that you had. Some of that advanced feature quickly being touched upon. So this is kind of a move from monolith to modular. So the common patterns emerging where you declare some components in multiple templates files. So you look out for those common patterns. And in this example for nested stack, so stack A is the root stack for all the other nested stacks in the hierarchy. So you whatever the common patterns were there, which you would consider that all the other stacks should have, you will put them in the root stack and call them a parent stack, and then other stacks could actually inherit them. For other business units, for example, you could have some stacks which are only using those parent stack, but have their very peculiar way. But other stacks you could have like their hierarchy going down at the bottom. The risk of this nested stack is quite useful, but there is a risk that it increases your blast radius. That if the parent is corrupted or has a problem, this problem will propagate down the hierarchy. Feature is that, for example, if you have outputs of first stack, you can use it in the second stack to get the dependency going and have the parameterization going. So you can use outputs from one stack to in its child stacks. Another advanced feature is cross-stack references. So you can basically, let's say there is an output from stack 1, you can use that the way in the nested stack. It doesn't have to be a nested stack. You can use it in an independent stack as well and use that output variable. It's a kind of dependent, and if one fails, the other one will also fail because of output not being produced. But this is a very, very good feature, and customers have appreciated that. There's a couple of very newer features. CloudFormation registry. This registry basically lets private and public extensions that are available for use in CloudFormation account. And what are extensions? So extensions are artifacts registered in the CloudFormation registry that augments the functionality of CloudFormation resources and properties. So I can create my own resource, which I believe that it can be shared across across my organization. I will create that resource and put that in my private CloudFormation registry. And there are some third parties also who can put that data. For example, Amazon can contribute to this, as well as APN partners. For example, Datadog has its own extension in CloudFormation registry, and any of the customers, any of the users could actually use that extension. And CloudFormation CLI, this is again an open source tool that enables you to develop and test AWS and third-party extensions, very specific to CloudFormation registry. So you can use the CloudFormation CLI to register extension, both those you create yourself as well as the one shared with you with the CloudFormation registry. Okay. And briefly touching upon one third-party tool, which is quite handy. So if we go back to our example of where we created resources via AWS console, and later in point in time we realized that, okay, we should move towards using infrastructure as code, then we can use Format 2 to basically reverse engineer, create CloudFormation template from your AWS resources that are there present in your account. So going back to the previous slide that we looked upon, so reverse resource provisioning engines, it gave us the benefit of easy automation, reproducible. But is this the end goal? Not really, because even though there is a lot of modularity available, there could still be configurational syntax errors and very specific coding practices required for YAML and CloudFormation. So there is no abstraction. We'll have to provide a lot of details. The details that you were providing on AWS console, you still have to provide as properties, as parameters in CloudFormation template. And also is a bit far away from your normal coding practice, the languages that you use and normal and what you use on a day-to-day basis. So where do we go from here? There is an intermediary stage before we get on to our end goal, where we actually use code generators and basically very unique tools written in Python, Ruby, Go, and you will find many online. So these basically give you a coding format where you can actually write real code and have the desired state. You can use the programming constructs like if, else, etc. And then this middleware will actually create a CloudFormation template for you. So it creates a DOM-like structure and solves the purpose. But we can see what good looks like. So that's where we look into AWS Cloud Development Kit, CDK. We like to call it infrastructure is code, because this is where we feel most comfortable with coding in our own programming languages, where developers are the team who has been developing applications, deploying on-premises or elsewhere. They can use the same programming constructs and syntaxes to basically deploy infrastructure code as well. So what is AWS Cloud Development Kit? So CDK is basically an open source software development framework to model and provision your cloud application resources. You can see an example of code there. Use your familiar languages, classes and methods and constructs that you're most familiar with, and create infrastructure code. With CDK, it is much faster than the previous tools because you work directly with your familiar language. You also have the tooling support from the programming languages that you've been using. For example, autocomplete, inline documentation, debugger, linting, etc. The languages currently being supported are Python, JavaScript, TypeScript, Java, C#, and Go. We recently launched it a couple of months back. It's in developer preview right now. And that covers quite a lot of spectrum of modern day programming languages. And the most important part is that you're able to build your own abstractions with of infrastructure and application. So the main components are that you have a core framework of which is basically inherited from CloudFormation, because CDK eventually uses CloudFormation template. It does not bypass. It is not a new service. is basically is the man in the middle, which will actually simplify your day-to-day job. If you've been using CloudFormation template, you move to CDK and it will do the whole heavy lifting of creating CloudFormation templates for you, and as well as deploying it, creating the resources, managing, updating it. So the three main components are core framework, AWS construct library, and the CDK CLI. And with the core framework, you can create and structure your apps that contain one or more stacks. We've seen what are the stacks, and these are like a resource area one-to-one mapping to the CloudFormation. Okay, so whatever you can do in CloudFormation, you can create identity like cognito user pools. You can create via CDK. You can create identity user pools, identity pools, any such resources you can create via CloudFormation. You can create using CDK. Construct library is a set of components which are crafted by AWS to create resources for specific services. So this helps to decouple libraries and use only the dependencies that you need in your project. So basically, the problems that are commonly used and have been solved before, you don't have to solve them again. James will guide you through some of the constructs which help development of your infrastructure as code, because you can utilize those constructs. CDK CLI is basically where you would run CDK specific commands. So this is an example, a few lines of code. And if you dive deeper, this is creating a new VPC, an ECS cluster, and application with an application load balancer, but just providing the name of the Docker image from Docker Hub and the number of maximum availability zones and VPC. That is it. You don't have to do anything more. And behind the scenes, CDK will generate around 829 lines of CloudFormation template with separate VPC subnets, internet gateway, routing tables, and lots of other resources, in total 37, with as many lines of code. So this is the magic which CDK does for you. Let's look at the development workflow very quickly. We start our project by executing CDK init. That will generate a project structure for you in a specific programming language. Once we're done with that stage, we build the project using our programming language specific build command. Then we try to synthesize the code. Synth process is basically creating a CloudFormation template from your code. And then the next part is basically, before we deploy, you will do a CDK synth and CDK diff to see what happens. And then the next stage is where you actually deploy. And CDK deploy will actually push the changes to the AWS CloudFormation service. And from there, the service will create cloud resources on your AWS account. This is which completes your CDK like development process and deploys your resources. Let's put it in context of CloudFormation service, which we just touched upon, and see the differences. There at some point of time, it's a common construct, but it creates a layer on top of AWS CloudFormation service where you have CDK application source code, which creates different templates, and then eventually it goes to CloudFormation service, and then on journey is same. So some of the CDK constructs, for example, serverless, you have Lambda, API Gateway, DynamoDB. These are the construct libraries, etc. I will give you the links to go to them and try them out yourself. And at this point of time, I'll hand over to James to take you through a hands-on exercise with AWS CDK. AWS, James, I'll just make you a presenter. Thank you guys for staying with me so far.
Okay. Excellent. So hopefully that screen share is working. Someone shout if it's not.
Yes, it is. It's working fine.
Thank you. Lovely. So yeah, thanks, Nitin. So what I'm going to do is hopefully, if the demo gods are smiling on me this evening, is I'm going to more or less live code a little environment that's going to consist of a Lambda function, and that's going to be hooked up to API Gateway so that I can reach my Lambda function over HTTP. I'm going to build and deploy all of this using CDK. So I've got a blank directory here, and the first thing I'm going to do is ask CDK to build me the sort of template structure for a blank project, and I'm going to build it in Python. So I'm going to use that CDK init command, and so this has written out a bunch of the files that you need to get started, and it's also created me a Python virtual environment, which I'm just going to jump into. So the first thing I'm going to need to do is in this setup.py file, which is a fairly standard Python package component, and it's got a section here that lists the libraries that we need in order to operate. CDK has added the core library here for me, but I actually need to pull in a couple of extras. So I want the AWS Lambda library and the AWS API Gateway library. So these are the libraries that contain the constructs that Nitin was talking about. So I can now set that all installing in Python. And while that gets on with that, I'll just quickly show you the other components of my CDK application. So the main one is app.py. If you think of the little diagram that Nitin had, where you had the app as the sort of root component, this app.py is that. So it's basically going to describe all of the stacks that make up my application. So CDK has created me some boilerplate based on the directory name that I was in when I ran the init command. It's initializing this app object, and then it's created an instance of my my demo stack. And then finally, it synthesizes the CloudFormation template. So if I was going to add more complexity, more stacks to my environment, this is where I would do it. But for the purposes of the demo, I'm not going to be making many changes to that file. The other component then is this, this stack file. So this was the next level down in the diagram with the hierarchy. And this file is where I'm going to be describing my resources. So you can see it's just a regular Python class. It's inheriting from a CDK stack type. And there's even a helpful comment that says the code that defines my stack needs to go here. So this is where I'm going to start defining my Lambda function and my API gateway. Before I do either of those things though, what I'm going to do is I'm going to make a directory for my Lambda code to live in my project. And I'm going to just open a file in there called hello.py. And I've got some code I wrote earlier. So this is my Lambda code. So this is going to actually execute when the API is visited by a client. So I have a handler function, which is going to log out some debug information about the event it received. That's just going to go to CloudWatch logs. But what it's going to do is return to API gateway a status code of 200 for success. We're going to set the content type to text/plain. And then the body of the response will be this hello CDK you have visited, and it will tack on to the end of that just the path from the original request, just as a way of showing that it's received and processed the request. So that's my Lambda code. So now in my stack, I can just come back in here and I need to tell CDK that it should actually include that Lambda function in my stack. So I'm just going to start writing in Python that I'm going to have a resource called my Lambda, and I'm going to get from the AWS Lambda library. Whoops, I've missed a step. I need to import the Lambda library and API gateway. But now I've done that, I can actually just define my function by using these Python classes. So you can see that as I'm typing, I'm getting all the usual sort of code completion stuff popping up in my editor, which makes it much easier to author stuff using CDK than it does just in JSON or YAML. There's a couple of pieces of boilerplate. So the first one is the parameter defines the stack that this resource belongs to. So that's this stack. And then you have to give it a resource name. So when we saw the example template in YAML, under the resources heading, we had a list of resource names. So this is the resource name that CDK will use when it renders the template. And then I've just got some properties I need to fill in. So the first one is going to be what runtime do I want my Lambda function to run in? So there's some helper classes here in the CDK to help me provide the correct values, so I don't actually have to go and look up what the values I need to supply are. So I'm going to run it in Python. I need to tell it where to get the code. So there's another helper class that's going to pick up the code from the file system for me. So I'm going to just read it from that Lambda directory. So that's just telling CDK, whatever's in that local Lambda directory, I want you to use that as the contents of my Lambda function. And then the final thing that I need to supply is the handler that Lambda should actually invoke. So this takes the form of the file name and then the function name in the file. So that's all it took to define my Lambda function. Let's have a go at deploying that. So I've just gone straight for the CDK deploy command here. I didn't do any of the synth or diff or anything like that. CDK has cleverly worked out that because I've just gone straight for deploy, it needs to do all that stuff in the background for me. And what it's actually done is synthesize that template. It's preparing to deploy it to CloudFormation. And now it's calling out to me that actually there's some security related changes that I might want to inspect before I just go and deploy this. So there's, we can see here, there's a service role for the Lambda function to be using and so on. And these aren't things that I actually put in my code itself. This is where the construct for the function in the AWS Lambda class has expanded into all these other resources for me. So I'm happy with those being deployed. So I'm going to say yes. CDK then packages up that Lambda function from disk, publishes it, and then starts the CloudFormation deployment process. So while that's going to get on with that, just want to cover some of the features that you can use for building Lambda functions with CDK. In my case, my Lambda function just has a very simple hello.py file. There's no additional libraries that I'm installing or additional resources like images or so on. If I was to include those, then you can actually have CDK build the function for you as a zip file, and it will build that inside a Docker container. So it will actually manage downloading the Docker image that represents the Lambda runtime environment that your function will be executing in. So in my case, it would download Lambda's Python 3.8 runtime, and then it will copy my code in, do all of the necessary install and build, and then it will use the zip file that results from that to deploy to Lambda. If it didn't do that, then I'd be at risk of it building macOS specific binaries for some of the dependencies maybe, and those won't work when they're uploaded to Lambda. So my stack's finished. It's reported success. I have a stack on, so I can go and find that in the console if I wanted. But a Lambda function by itself doesn't really do much in this case. So what I need to do is come back to my stack here, and I'm going to add an API gateway. So in the AWS API gateway library, I'm going to pull out a Lambda REST API, and this is another construct that's going to take just the two parameters that everything has to take. So my API as the name, and then the only other thing it needs to know is which Lambda function should it, which handler should it be using to handle requests to the API. So I can just pass it the my Lambda variable, which is a representation of the function that will appear in the stack. And that's literally all I need to do in order to add an entire API gateway hooked up to my Lambda function. So now I've done that, I'm just going to go back and do CDK deploy with my new version of my template or my new version of my application. And we can see again, I've been prompted with what is actually quite a large number of IAM related changes in this case, because this API gateway construct has expanded into all of the necessary permissions for API gateway to invoke my Lambda function and to write logs to CloudWatch and so on. So once again, I'm going to say yes, and I'm going to leave that deploying. And while that's doing, what I will do is I will show you by way of example the CloudFormation template that's actually being generated by this application. So this is being rendered in JSON rather than YAML in this case, but we can see this is, a regular CloudFormation template. So there's a resources node. Inside that, I've got a list of the resources that are being generated. So if I pop open this view, hopefully you can see that there's 2, 4, 6, 8, 10, 12, 15 or 16 resources that CDK has created on my behalf, even though all I did is put one line in my code to add that API gateway. And so there are things like these proxy configurations to hook the Lambda up and pass the parameters in. So this is where the Lambda function will receive the path information in order to print out the hello message. And then there's a deployment and a stage. These are all API gateway constructs that if I was writing the CloudFormation template myself, I'd have to go and read the documentation, figure out what the correct values were, figure out which values from other resources I needed to refer to in this one in order to make everything actually hook up correctly. So this is where the power of CDK and its constructs really comes in. And one of the other things that's quite useful here is when it's configured these IAM permissions. So here's a permission to invoke the Lambda function. Because CDK has sort of got all this logic for how to link the resources together, it's creating me these very tightly scoped IAM policies that will only allow exactly the right Lambda to be invoked, or if I was allowing the Lambda to do actions with S3, for example, it would be very tightly scoped to the bucket or the prefix that I'd done. And I wouldn't have to worry about trying to sort of construct an IAM policy and then getting frustrated and putting resource star in there when that's not very secure. So this is sort of the best practices that come wrapped up in these constructs as well. So while I've been talking, my stack has finished updating, and we actually have a CloudFormation output to help me find the API endpoint that it's created. So hopefully I can make a request to that. And if I put hello/world on the end, my Lambda function has been invoked by API Gateway. It successfully received the proxy information, and I've successfully received my hello world message back. And that's how easy it is to get started with the CDK.
Excellent, well done. I think that's an applause because the demo gods did look kindly on you. Cool, excellent, well done. I have one or two questions, but I'm also going to open the mic up to the.
Before we do that, yeah, thank you for making me presenter. That's what I was going to say. Perfect, go for it.
Okay, yep, go on.
Yeah, so we open the floor for the questions, but this is the slide which I was talking about. It has a lot of follow-up content where you can get started. You can contribute to CDK development, and you can also engage with us via our GitHub channel. That's all. Thank you all.
That's great, thank you. So do we have any questions from anybody? If not, I'll get started with some of mine. Is there a specific, what's your best practice, recommended best practice on ways of reducing drift? And do you regularly, is there anything around recreation versus migration when it comes to CloudFormation?
So reducing drift. So drift is basically a side effect which has come because you have switched your practice from using infrastructure as code to making changes via console or via any other mechanism. So the feature of drift detection is to basically overcome that side effect. So to reduce that, yeah, best practice is that you actually go ahead with your CloudFormation updates, where update your stack and deploy the changes via infrastructure as code. And sorry, I missed the second part of your question. Please ask again.
Yeah, so how do you avoid the situation, or what's the best practice around avoiding being able to recreate a stack? Maybe you've had a stack you've created for a while, you've run in a lot of updates maybe. How do you make sure that if something happens that you can recreate it? Is there any like regular best practice about how you manage that?
So it's specific to CloudFormation service. James can add with the CDK part of it. So CloudFormation service is basically transactional. It is a very, very great feature of CloudFormation service that if any of part fails, the whole CloudFormation stack will be rolled back. And if for any reason that you realize that stack is deployed, but you may have to go back and change your CloudFormation template because the resources created are not as per your requirement, you can actually delete your stack from the CloudFormation service, and it can roll back the whole of the changes from your system. So that way you can actually manage the unwanted situations.
I'd also add to that I think some of the sort of the answer to your question comes from when you're sort of in a place of maturity with sort of your operations, where everything is driven by your CloudFormation or your CDK or Terraform, whatever tool you're using, and you do that on a regular basis. So maybe what you do is you tear down your dev environments once a week and relaunch them using the same CloudFormation template that you would use, say, for production. Obviously with maybe different parameters, so you don't launch as many instances or instances of such a large size. But that sort of helps grow confidence in the fact that your CloudFormation template is a suitable representation of what it is that you're running in your production environment. So it shouldn't be sort of a launch it and forget it kind of thing. You should really be sort of like taking advantage of the fact that CloudFormation will provision and deprovision these resources very readily for you.
Great, chaps. Last question around the CDK, etc. Can you run the Lambda actually locally? Is that possible as well, like you do if you were doing it using SAM? How can you do like local development with it?
So as long as you don't ask me to demo it, because I don't have it set up, I do believe there was integration announced recently between CDK and SAM. So you may be aware that SAM has the SAM local and the SAM invoke commands to sort of assist with local testing and debugging of Lambda functions and other bits and pieces. The integration there with CDK allows you to use CDK to be writing your infrastructure in code, and then use the power of the sort of the SAM local stuff integrates with that, so that it will actually provide the local testing, even though the rest of the stuff is written in CDK.
Great, thank you. Do we have any more questions?
I've got one quick one around CDK. When I first tried out CDK, which was quite a while ago, it can't have been long after it was sort of made GA, I noticed that there was not a huge parity between CDK and CloudFormation in terms of the constructs and then the resources that are available in CloudFormation. What does that landscape look like now?
So where we are now with that is really a story of at least two parts. The first one is that the CDK includes what it calls these level 1 constructs, which are one-to-one mappings against CloudFormation resources. So those are constructs that start with the prefix CFN, and they are exact mappings to the resources that you would be writing in CloudFormation if you did the template yourself, and we'll find in the CloudFormation documentation. And those are automatically generated programmatically from CloudFormation's specifications. And that generates like the CDK construct libraries based on those. So anything that CloudFormation supports, you should now be able to get access to in CDK using those level 1 constructs that start with the CFN prefix. Then the level 2 constructs are sort of a bit more like the Lambda function that I used in my demo, where they don't start with the CFN. There's a bit more logic behind the scenes. So you could see, for example, it was taking, like that code asset type in order to load the code off disk. And those are what are called level 2 constructs. So they sort of wrap the CloudFormation resource with a bit more intelligence. They might expand into a few more resources, but they're still a fairly direct mapping. And then the level 3 constructs are really the ones like the API gateway one that I used right at the end. And those are ones that expand into a large number of resources with quite a large amount of complexity. And those level 2 and 3 constructs are the ones that are written both by AWS staff for the CDK and also then by the community. So you should always be able to express anything that you can do in CloudFormation with CDK, but you won't always have the cool constructs that do the magic stuff on top of it for you.
That's great, thank you.
Cool. Excellent. Right, I will take back this.
Just had two questions, if that's okay.
I'll go.
Yeah, sure. Yeah, just the first question. So you gave a great demonstration. Thank you for that. And that was from your local environment. Could you describe how you would conduct that? So where you're not running it locally, so you've got a bit more governance around executing your deployments.
Yeah, so CDK actually has, I can't remember if if it's final now or if it's still in preview, but there's a feature called CDK pipelines that's been around that the team are working on. And what CDK pipelines does is using one CDK application, it will bootstrap itself a code pipeline that will be backed probably by code commit, but it can be GitHub and so on as well for your code to live in, and then pushing code triggers the execution of that same pipeline. And what that pipeline does is all the CDK sort of, it checks it out and does CDK deploy basically. And then should you need to modify the way the pipeline executes, you do that inside the same CDK application, and it actually sort of becomes self-modifying. So it updates its own pipeline, then executes its own pipeline to deploy itself. And so that is CDK's answer to sort of putting the more CI/CD workflow and the governance coming from deploying and managing this from a more central location.
That's great. The final burning question is the Corrado. Is it a G60?
No, it's 1.816 valve, which is probably for the best. All things considered.
It's cheaper to replace the starter than the supercharger. Brilliant. Thank you for that.
You're welcome.
Any more questions? Good. Okay, we'll move on to our second speaker then. We have got Alex Kearns from Inner Wisdom. He is a solutions engineer, and previously he has worked at BT on some of their AWS projects. He's also has spoken at Tech East as part of the Tech and Toast initiative. He is Vice Chairman of the Kearns Foundation, which he might tell us a bit more about, with his family, and he has also helped mentored young school-age developers and college developers through the Young Masters Tech Club. So, Alex, are you ready? And I will make you presenter.
Yes, I am. I'm good to go. You put me on the spot a little bit with the Kearns Foundation stuff. I'll give it 30 seconds and then we will be good. So yeah, the Kearns Foundation is a very small local charity that was established in 2007 as a result of, well, primarily it was coming from donations from my granddad's funeral. His wishes were that any donations went back into the community that he sort of lived and worked in, and like my family have always been involved in that charity sector, so it was kind of decided that we would start something up to have more control over how that money and who that money would be distributed. So we focus on really small grants of kind of up to £250 or so to under 18s and community groups in primarily Norfolk. To keep that sustainable, we've got a small kind of log cabin that we rent out to people at schools and scout groups and those kind of community organisations on the North Norfolk coast, and that is that's our only source of income really. Obviously for the last 18 months or so that's been quiet, we shall say, but finally things seem to be picking back up again, which is really good. We've got lots of great plans on how we can start to help the community get back on its feet after what's been a pretty rough time for everybody. So I mean, if anybody is interested in finding out more, please do get in touch or have a look at the website, which is just kearnsfoundation.org.uk. but yeah, this certainly isn't a plug. Just FYI. So yeah, I'm here today to talk about App Runner, which I think only came out about a month ago. It might have been a month ago to the day, and was a service that when it came out really kind of caught my eye straight away. And I think it's actually a message from Phil that summed up what was most attractive about the service, and it was that some people had dubbed it the kind of elastic beanstalk killer, which has been a very long-running service. I'll get into a bit more detail as to obviously what App Runner does, why you might use it, why you might not use it, and hopefully finish up with a live demo, which should all go fine. So yeah, just a tiny bit about me. I work with Phil at Inner Wisdom, a solutions engineer. I haven't been there very long. I've only been there a month or so, but have been quite active in the kind of tech community in Norfolk and Suffolk. Originally, I've kind of come from a development and computer science background, but cloud has rapidly become my area of interest, and seems to be staying that way. And I've got a few of the certifications that yeah, come along with the AWS learning. And for any of you who don't have the certifications but are interested in doing some, I would wholeheartedly recommend them, because not only do they take you on quite the journey of learning about lots of different things, they are a nice thing to have on the CV to validate that you know what you're talking about. So this is kind of a reasonable extract from the App Runner product page, and I've cut a few bits out to make it a little bit less verbose. But the crux of it is that App Runner makes it easier to deploy to the cloud, even for teams that lack prior experience deploying and managing containers or infrastructure. And the service has AWS operational and security best practices built in, automatically scaling up or down at a moment's notice with no cold starts to worry about. So comparing to something like Elastic Beanstalk, that was again pitched as something where you bring the code and we'll bring everything else. There was still a little bit of knowledge needed around what you wanted in terms of requirements. App Runner does extract things a little bit higher level, as we'll see a little bit later on, which makes it even easier to get going with your code. So let's have a look at what it actually does. I kind of want to start with this question, because the more reading I did about App Runner, this was a fairly common theme, and a lot of people came out and said, like, do we really need another way to run containers on Amazon? And I'd seen this drawing from a guy called Forrest Brazil on Twitter. He works at A Cloud Guru, and if you don't follow him on Twitter, I would definitely recommend it. He puts out some really good content. A lot of it's quite satirical. He's done some stuff with written songs about trying to fit every AWS service into a song, which was quite a funny one to watch. But yeah, he put together this kind of flow chart of, if you're looking at running a container on AWS, how could you run it? There are probably some on here that I missed, but when I ran through this, it seemed to fit fairly closely. And obviously I've got App Runner right at the bottom down here, next door to its neighbor with an Elastic Beanstalk there. So straight away we can see that actually there are a lot of ways to run containers on AWS, but AWS as a platform obviously caters for everyone. The one thing I think I've noticed in recent times with more and more services coming out is services seem to be going further and further towards allowing developers who haven't got or necessarily want the experience of infrastructure to be able to get things into the cloud. You look at things like what's the App Runner, even things like Lambda. There's not that much you need to know about to get Lambda working now. Obviously, with things like the CDK, that's a huge thing that if you can write code and understand the basic pieces that fit together, then in kind of 10 lines of code, you've got a full-blown secure infrastructure for a event-driven API, which is crazy. But yeah, I wanted to look at App Runner alongside some of the other kind of real common ways of running containers. So if someone came to me and said, okay, I want to run a Docker container on AWS, where should I look? Up until kind of 6 weeks ago, these would be the three things that jumped out to me. Going from kind of least complex, which is still reasonably complex, in my opinion, to obviously self-managed EC2s, where essentially, obviously, you have responsibility for everything. App Runner has come in at this kind of point. The reason the question mark there is because I couldn't find an icon for it, not because it's a questionable service or anything like that. But yeah, App Runner comes in to fill this gap of, I know I need a service that is going to have this much CPU and this much RAM, and I've got my code. Beyond that, I don't really care about anything else. I just want it to run. I want it to scale up when it needs to. I want it to scale down when it's got low traffic. And I don't want to have to worry about setting up auto scaling groups and target groups and launch configurations and everything else that comes with some of the most complex options. Or even when you go down the route of something like Fargate, where actually, if you wanted to have a load balanced website, you need to start thinking about the load balancers and then ECS services, ECS tasks, task definitions. The list kind of goes on and on and on. And sometimes all you want to do is just say, I've got my code, I want to get it somewhere on the internet, and that's it. I don't want to worry about everything else. And that's where App Runner really comes in. So these are kind of the headline features. So it really is a fully managed end-to-end kind of container deployment and an orchestration service. That makes it sound more complicated than it is, but under the hood, it is doing that for you. It is deploying a container and orchestrating the horizontal scaling when you need it. It's giving Amazon a lower barrier to entry. If you ever used Google Cloud Platform, and especially Cloud Run, which is very similar to App Runner, but a bit more established, then you'll kind of see why Amazon have gone in this direction. There's actually quite simple pricing, which is always nice to have. And one thing that was in the original launch announcement, but I haven't seen materialize yet, was budget controls, where you could say, when my application or my service has accumulated this much usage, stop. So that I haven't seen the console yet, but yeah, it was in the original launch blog for it, so maybe it's a feature to come. Although it is a kind of really abstracted way of deploying these things, it does still have support for things like auto-scaling. So if you do have a service that is particularly peaky in its traffic, it can do that for you. It will automatically take care of things like health checks and naturally load balancing as well. But as we'll see, the options it exposes to you in comparison to something like ECS are much more limited because of the audience it's probably aimed at. So why do we need App Runner? So on the whole, I would say AWS is necessarily complicated. I don't like to say that it's overcomplicated, because I don't think it is. For the kind of workloads that run on it, it needs to be complicated in areas, because otherwise you wouldn't be able to configure it how it needs to be configured. But with things like DevOps and sort of smaller businesses and sort of one-man shops becoming more prevalent, what we are going to find is that the budget for an ops team is going to disappear, and people are going to say to developers, well, if you've written the code, can you put it in the public domain as well for us, please? And obviously services need to exist to do that. There are things like Heroku and what's the one? Vercel, I think is one I can think of, which do those kind of things where you can just kind of throw code at it and it deploys on a URL for you, and that's that. But sometimes there's that kind of middle ground of, I want to deploy it somewhere, but my business needs the safety or the tick box to say it's deployed on AWS, or it's deployed on Google or Azure to meet a certain quality assurance, what's the word? Like ISO certification, something like that, where a smaller provider might not cut it. And like I've kind of reiterated all the way through, is sometimes you just want simple. Sometimes complications are necessary, but actually I kind of have a fair bet that a lot of the time, when the requirement is, let's get some code running in the cloud, whether it's production or whether it's actually just, we've built something as a proof of concept, let's demo it to a client. You don't want to spend a week knocking together VPCs and subnets and everything like that. You just want to get it on a URL and show them. And that's where App Runner comes into its own. So, fingers crossed. Let's see how this goes. I've also got the pricing up, so I will show you afterwards the pricing and how that is all calculated. Just in case the demo doesn't go well, I have got 2 running already, and the demos does sometimes take a little bit of time to get going. So if it does look like it's going to be a slow evening, we will fall back to them. So there are kind of 2 ways that you can start with your source code repositories or your source for your App Runner service. One is coming from a container registry. At the moment, it's just ECR that's supported, both private and public. Alternatively, you can link it up with GitHub, and you can then deploy straight from a repo. Let's go for the GitHub one first. At the moment, it is just GitHub. There is no option for things like code commit or Bitbucket. That does seem to be fairly common in the new services, is that GitHub gets the connection first. It might be one of those things where actually, given the audience it's aimed at, the chances of people using code commit is perhaps smaller as a wild guess, but yeah. So I've got a repo in here set up and ready to go. All this repo has got in it is literally just a JavaScript file with very little in, just enough to serve a very simple application, and a HTML file, which is our index page. And that's it. There's no Docker file, no Docker Compose file, nothing container related. This could just be a plain old static website served by Node. So we always have the choice of whether we want GitHub to trigger it automatically, or whether we want to do our deployments ourselves. There is a $1 per month charge for the automatic one per service, so watch out for that if you do have a lot of them. So I'm going to do manual because I don't know how big the bill is from my experimenting yet, and I don't want to risk any more. You can put a App Runner YAML file in your repository and set up all of these kind of settings in there. I didn't do that because I think it's easier to explain as we go through on the UI. So at present, for ones where Amazon builds your container for you, there's just 2 runtimes available, which is Python 3 or Node 12. Ours is Node, and then all you need to do is you tell it what you want to run in order to build your application. So for me, I've got one application dependency, which is just Express to serve the static page, and this will install that for me. And then to start it, I just run that, I think it was. Yeah. So what you might be able to start making the connection to is, if you think of this page as your Docker file, so you're saying, rather than saying I want to use a from Node.js 12 image, you choose Node.js 12 there, and rather than saying, okay, I want to build my application by running a command in my Docker file, you put your command in here and onwards, and rather than having your entry point to your container being this, you specify it in here. So it's quite nice in that it's written in a way that is, if you don't know about Docker, you don't need to. But if you do know, you can kind of make the links as to what it's doing and the port that it's going to be running on. So for me, we're running on port 8080. So you can do your usual naming in here. You can choose your virtual CPU and your memory. It's fairly limited at the moment, so it's 1 CPU and then 2, 3, or 4 gigs of RAM, or 2 and 4. Auto scaling is, again, a nice simple way to look at it. Rather than based on things like CPU or memory usage, they base it on concurrency of requests. So they say, for this one, we can say, when my application receives more than 100 current requests, I want to start scaling out. I want to have one instance provisioned and ready to go, and scale out no more than 25. So you can limit your budget a little bit that way. Health checks, if you're familiar with how normal AWS auto scaling groups do them, it's fairly similar. The only thing you can't do with this is you can't specify where it does the health check. So it's going to, by default, just do a health check at the root of your service. So you can't ask it to check your health check at /health check, for example. But again, that's the price you pay for simplifying everything else. However, you can still go down the route of giving it a instance role and KMS keys if you want to encrypt any data that's stored when they build the thing for you. So other than that, you also get the chance to review everything, and that's it. I'm not going to wait for this to finish because it will take probably 15 minutes or so the first time to build everything. But this here is exactly the same as this one. And this here is the index file that I've got in my repository. So it's a really nice, simple way to get simple things deployed. The other thing you can do is you can obviously deploy from a container registry instead. Other than this first page, the settings are all the same, so I'm not going to go through it all again, but I have got running an example of this. So I found the Nginx web server Docker image on the ECR public registry. So I built an image, I built a service off of that. Same configuration as you normally get, port 80, because that's what the web server will be exposing on. And that similarly just gives us a plain image there. So it can get complex if you want to, because you could build your own image somewhere else and just run it through App Runner. If you build your own image, you're not limited to Python and Node because you've naturally got the full container runtime. The only thing I found so far, which is a little bit of a confusion to me, is the auto scaling. So I wasn't able to overly reliably trigger auto scaling. So last night I tried some load testing with around 1,000 requests a second being thrown at one of these services, and even setting the concurrency as low as 10 couldn't get it to scale out. So either my load testing was was not working as expected, or there's something else going on behind the scenes that is a contributing factor to the scaling, that I may reach out to someone at Amazon to try and find out why and how that works. Just to round everything off, I want to look at pricing, because it can look confusing, but it's actually quite simple when you understand it. So when we set up our service, we chose a minimum number of instances. So by default, it's 1. You can choose however many you want. These you will always pay 0.007 gigabyte per gigabyte hour, regardless of whether your application is receiving requests or not. If you pause it, then you don't pay it. If it's running like this is now, I'm paying the 2 gigs, whatever it was, every hour. As soon as your application starts receiving requests, that's when you start paying for CPU. So it doesn't quite do the scale down to 0 that things like Cloud Run on Google do. The lowest it will scale down and still be running is these. And that's how Amazon can get around the cold start problem, because they are still pretty much running, just not taking up any CPU space, just reserved in RAM. When you start processing requests, you then start incurring this cost. And what I can show you is this one. My session's expired. We can see, if we go back a few days and look at this. So yeah, so I was testing out with a fair number of requests coming in, and got it to scale out to sort of 2.6 at one point, or an average of 2.6. So I think maximum was 3. But this active instances will be 1 here when I was testing it before this call. But yeah, the nice thing is that until you receive requests, it's sitting at 0, and you're only going to be paying for that one, which is quite nice. And then you obviously got these things as well. So the automatic deployments that I mentioned, about $1 per month, and then you pay a bit for how long it takes to build if you're going for the GitHub route, plus the usual CloudWatch and data transfer, etc. rates. They do give some nice examples here of how much it can cost per month. So I do have a play with that. If it's something in development and you can pause it overnight, then that's a great way to run it and save some money, because pausing it it's just a 2-click process, and then within sort of 10 minutes it's up again. So yeah, that's everything I've got on App Runner. I think as a service, it's definitely got a lot of potential. It's something I really want to try out on some heavier workloads, I think, to see how far you can push it before simplification becomes too much of a drawback. But on the whole, I'm actually quite impressed for a new to market service.
Great. Well, thank you very much, Alex, for that. Do we have any questions for anybody? Okay, so my only question really was, I get it that it's focused on getting people with no AWS experience kind of going, and that's kind of cool. Can you then see what it's actually done? How much into the nuts and bolts can you then progress, or if you wanted to do that, do you then just have to go into the actual, then figure out how ECS works or whatever? Does it expose any of the actual inner workings and governance to you?
It doesn't, unfortunately, no. So the only, I guess the dropping off point is you start to get familiar, if you read the documentation, with things like load balancers and health checks, instance roles, and once you start to piece those bits together, then I guess something like Fargate is probably the next logical step, where you aren't having to worry about EC2 instances. You're still on that same idea thread of, I want this much CPU and this much memory, but just having to do a bit more yourself. But yeah, you can't go on to like ECS or EC2 and see that it's provisioned an instance for you. Unfortunately, I think it's definitely a service that in its early stages has been aimed at capturing that part of the market that wouldn't otherwise look to AWS because of its complexity. However, yeah, it's going to be hard for them to pull away the people who would normally be shooting straight for something like Google, and yeah, getting everything into the Amazon ecosystem, which I guess is where, once you start getting a few things in, you start to look around and then realize that it doesn't take too much learning to progress from there onto something else. It's a good gateway, I would say, but would be more than adequate as a standalone service if people never progressed off of it.
Excellent. Anybody else any questions?
Hi, it's James. I've got an answer. So just following up your point about you didn't manage to get App Runner to scale up when you sent it a bunch of requests. I've reached out to the internal App Runner community, and it seems the answer is it needs at least 60 seconds of that request rate being exceeded, the concurrent request rate being exceeded, before it triggers the scaling up. So yeah, I don't know if that matches your test, but yeah, if you've got more questions on it, feel free to drop me a mail.
Thank you. Yeah, I think I ran, well, the load tests I ran were delivering between 100 and 1,000 requests a second, depending on how hot I let my lap get. But yeah, how concurrent they were, I don't know. So that's something I need to look a bit more into.
Yeah, I mean, if you're just returning your index.html page, then it's probably not going to be in flight for very long. So
yeah, so I didn't want to unleash kind of cloud-powered load balancing in case my account got suspended.
Cool, excellent. Anything else, anybody? Right.
Well, yeah, all I'll say is if people do have any questions about it and want to pick my brain or well, anything AWS really, I'm always up for a natter about this kind of stuff. On Twitter, it's just Alex_Kearns, or yeah, Google my name and I'm sure it'll appear somewhere. Yeah, feel free to get in touch.
Cool. Well, thank you again, Alex. That kind of actually that brings us nicely on to the next little one or two things before we say good evening. The next thing is we sent out the survey last time. Most people gave us a good response. There was a couple of things about wanting this session, so we put this session on. I'm kind of about more stuff like that in a minute. The other thing was around how to communicate and be a community outside of these actual events. So I reached out through the extended AWS User Group network and have worked on getting us a chat platform, and basically ourselves and a few of the other UK-based AWS user groups have set up a Discord server that you can come and chat. And Ipswich has got its own dedicated chat, and also we can just talk with each other, but it has other channels and other things for you to go and explore. So I recommend giving that a good look at. There's quite cool stuff. Last night there was an AMA event, Ask Me Anything event with Jeff Barr. That was very popular on there, and you're all more than welcome to take part in these events. The next one is Query Corinne, so that's going to be I'm not sure what's quite going to happen there. It's going to, the master of the ship post is basically coming, so we'll see what happens. But please take a look and join and have chats between these sessions. That's good. So join up with Discord. We also have AWS Ipswich is our Twitter account. You can follow that, and I do push out tweets occasionally through that platform of updates and that kind of thing. So that's all great. Second thing, and some of you who have certifications already, fair enough, but AWS are pushing the global certification challenge. They moved it up a level, so they were doing practitioner for the start of the year. Now in this quarter or this half, they're doing associate architect. If you want to get involved with that, there is some timelines for doing that for the next 3 months, and they will give you a 50% discount on passing your solutions architect. So please take advantage of that if you want to become certified. And then the last kind of thing is the up and coming events. So we will hopefully, I'm increasingly confident of this, not to sound like the big man in number 10, but we will be doing some sort of in-person meetup, hopefully in October. Because everything's back to normal then. That's the thing. So hopefully we're going to then. I'm looking for speakers and people want to talk. So if you do want to talk, let me know. I am also I'm banging on the door of people that I know to come and speak. So that would be good. The UK user group are doing an online one on the 14th of July. There's an Us See Me Anywhere event with Query Corinne. That's going to be hilarious. And then lastly, and most exciting, trepid, I don't know, scarily, nervously, there is reInvent 2021, and it will be in person in Vegas. Some of the keynotes and other things will be streamed, but it will be there. So it'd be interesting to know if anybody's planning on going. I think I would go if I could have some sort of guarantee from Boris that I can get back, and that's the quarantine and coming back is the biggest thing. So I'm looking out for some sort of double vaccine visa thing that allows me to come back even if he shuts the whole thing down, kind of thing, because that's also obviously that bangs up against Christmas and also that other half's birthday, so I can't really quarantine that much. So I'd love to know if anybody's actually planning going out there. I am on the fence right now. Let's see how the summer goes before I even think about an autumn trip to the States. It's just scary saying that stuff again. It's about the last thing I did before the war was a pandemic, was go to the last event. So
think,
go on.
Tickets are open now, aren't they? You can now buy tickets as well.
Yeah, registration opened I think yesterday or the day before, so you can go and buy one. The strange thing is, to be honest, it's a bit low-key on the COVID front, and also like the cancellation policy. I was expecting a little bit more like it's at the moment it just says we're going to do what the government tells us to do. It's like I was expecting a little bit more from Amazon on the this is how we're going to push it, like just above the bar to make sure everybody really does feel safe. Maybe more will come out on that. And it's like the cancellation policy didn't really affect the fact that you might get COVID. It's like we won't give you your money back if you cancel within a week of going there. But if like the government stops me or I've got COVID, it's like, well, surely that's wrong. So I thought it was a bit harsh when I looked through some of the terms, but maybe that will change. Anyway, well, thank you for our speakers tonight. It's been great. This is Infrastructure Focus, and I bid you all good evening. And I will hopefully see you next time in a pub in person, and at least we can then have a good drink together. And that's the main aim of the in-person meetup. Great, and see you then. Good evening.
Yeah.